Okay, good evening, everyone. My name is George Sarrinikolaou. I coordinate the capstone workshop course in the Sustainability Management Program, and I'm one of the advisors. As most of you know, and for those of you who don't, the Sustainability Management Program is a hands-on, very practical program. And so rather than have students do a master's thesis, we actually ask them to do the very thing for which they're training, and that is to serve as sustainability managers. And so tonight, what you will hear about is 4 projects in which teams of students did exactly that. They worked alongside sustainability managers on a pro bono basis, that means free, to analyze, try to solve, come up with solutions to some very, very complex and very different problems. And each of these teams will take 10 minutes to tell you about what their issues were, how they went about dealing with the problems, and some of the solutions that they came up with. What I'd like you to pay attention to as these students make these presentations is the broad array of projects, the various tools and strategies that each team used to approach these problems, and to keep in mind how each team did that and what they came up with. While you do that, keep in mind that these are students who are all in the same program, but who are now able to take on a wide array of sustainability problems and make sense of them. And that's really a testament to the work that they've put in, not only in this course, but throughout their time in the program. The way that our program will work tonight is as follows. I will introduce each of the presenters. The presenter will give a 10-minute presentation. We'll take a few minutes of questions, so be thinking about really tough questions to ask them. And then we'll take a break. You can go back to enjoying the refreshments in the back. And a few minutes later, I will call you back for the next presentation. We are recording the event tonight and also streaming it online. So what that means is that if you have anything that makes noise, please turn it off. And if you have a question, please wait for the mic so that we can record your voice. The first of our projects has to do with public transportation in a city full of cars, Los Angeles. Christopher Mangieri is the presenter, and the faculty advisor was Thomas Abdallah. Christopher.
Hello, everyone, and thank you again for joining us this evening. My name is Chris Mangieri, and I will be presenting on behalf of our group's capstone project. Our team was tasked with developing a sustainable return on investment tool for the Los Angeles County Metropolitan Transportation Authority, our client. In addition to developing this tool, we were to apply it to a specific project at LA Metro. A brief overview of what we will discuss this evening. We'll give you a background on LA Metro and the scope of our project. We'll talk about what an SROI, a sustainable return on investment, is and why it matters. We'll go into some specifics of our model, including fuel use, emissions, and avoided healthcare costs. We'll talk about our overall findings, brief case study, and then wrap up with recommendations. So LA Metro's first line was serviced in 1990 and has since expanded to include 4 light rail lines, 2 heavy rail lines, and 2 bus rapid transit lines. Here are but a few of LA Metro's many sustainability initiatives. The scope of our project is LA Metro's entire bus fleet since it's been converted over to compressed natural gas in 2010. The goal of developing this tool, however, was to make it so that it could be applied to any project at LA Metro, including those seen here. So before we go into the specifics of our model, I want you to first understand what an SROI is and why it matters. On the left, in the blue box, you have a traditional return on investment broken down for you. In the orange box, you have a sustainable return on investment, which builds off of the traditional ROI, including internal and external, social and environmental costs and benefits that are important to stakeholders, but often overlooked by standard capital budgeting methods. So that sounds great, right? Then why isn't an SROI commonly used as a valuation tool? There are two reasons for this. One, it is extremely difficult to quantify specific social and environmental costs and benefits. Two, a lot of the values that an SROI can quantify don't always provide a direct return to the investor. However, for LA Metro's case and government entities' case, this does not matter as much. LA Metro's sole purpose is to provide services for the community. That being said, if LA Metro's bus program did not provide profits to them, they would still run it no matter what because it provides a necessary public service for the community. What we're saying is that an SROI tool will never replace an ROI tool. However, it can show you supplemental value that is not normally recognized with a traditional ROI. So here we have value creation from a standard ROI and SROI as well. The ROI is represented by the blue line, and the SROI is represented by the orange line. On the x-axis, you have your return on investment as a percentage, and on the y-axis, you have probability. Now, it's important to note that at 50% probability, that's where your mean value is. So right now, ignore the returns that are shown on the top. What matters here is that the SROI provides value added to the stakeholder. That value added, you can see as the difference between the two curves. You can ignore the green line all the way on the left for now, or excuse me, on your right for now. We'll get back to that later. So our model incorporates 4 different areas: waste generation, water consumption, electricity use, and fuel use. In the interest of time, we're just going to talk about fuel use and emissions generation tonight. I want to take your attention first to the left side of the graph. This information is user inputted data. This was taken from the annual sustainability reports provided by LA Metro, as well as state-run agencies in California. The table on the top right calculates total emissions generated from LA Metro's compressed natural gas fleet. These are broken down into carbon dioxide equivalents, sulfur dioxide, nitrogen oxides, and particulate matter, PM 2.5. Similarly, the table in the bottom right calculates total emissions avoided. Total emissions avoided as people using the bus system instead of driving their own cars. Again, these are broken down into emission specifics. So now that we have our emissions generated and our emissions avoided, we need to put a dollar value on these. This graph shows healthcare costs of particulate matter 2.5 in California. The low and high values were taken directly from the regulatory impact analysis conducted by the EPA for the Clean Power Plan. And now I'm sure you're saying to yourself, why is there such a large range in values? This is because the Clean Power Plan pulls data from 3 different models that value emissions differently. To tackle this, we had our model ask the user how they value emissions as it relates to alleviating health impacts as well as mitigating climate change on a scale of 1 to 10, 1 being the lowest value, 10 being the highest. For example, if a user were to input a value of 5, it would take the marginal increase value here in the middle in yellow, multiply it by 5, and add it to the lowest value, creating your realized dollar per ton for PM2 emissions. This is done as well for carbon dioxide equivalents, sulfur dioxides, and nitrogen oxides. So now that we have our emissions generated and avoided, as well as a dollar value for those, we can calculate healthcare costs avoided. In this scenario, using an emissions importance factor of 5, we were able to calculate the benefits at top, shown here, as you avoided gasoline usage, and the costs for LA Metro's compressed natural gas usage. Now, the specific values aren't what's important, because those change based on the emissions factor. What's important is the positive benefit that is created here, that you can see in the bottom. The positive benefit that is relative to LA Metro and society in the region. Again, referring back to this graph, you have your ROI in blue, your SROI in orange, and the emissions avoided benefits as the value added in between, moving that curve to the right, creating more value. Now moving on to our overall findings. So in order to test the range of our model, we conducted a worst case and best case scenario as would be done in a traditional ROI. We also conducted an expected case scenario seen here in the middle. Now I want you to look at the worst case scenario here, because even in a worst case scenario, you have an NPV of over $450 million and an IRR of 26% for LA Metro and the surrounding area. Our model also includes qualitative values, such as avoided premature mortality and avoided morbidity. These values were also taken from the Clean Power Plan and are based on an emission reduction basis per ton. Focusing on avoided premature mortality, the two studies shown here, even under worst case, you can see that there are over 38,000 avoided deaths as a result of the emissions reductions associated with the compressed natural gas bus fleet. Now, this was done on a broader scale for the entire compressed natural gas fleet. What we also wanted to do is look specifically at social localized marginal benefits of a particular area to see if we can quantify those on a localized basis. So we decided to do a case study on the orange bus line. We used safety to measure improved quality of life, and we're able to find a $1.2 million in avoided costs for LA Metro as a result of implementing the orange line through reduced crime in the area. We used active transport to measure improved community mobility and access, assigning specific dollar values to fitness and health-related activities such as walking and cycling. We saw a $3.5 million benefit to society and the surrounding neighborhoods as a result of installed walking paths and biking paths associated with the orange line. We used job creation and property value to measure financial growth stimulation, seeing over 25,000 jobs and opportunities directly created as a result of the implementation of the orange line. We also saw a $1.4 million per year in property tax revenue increase for the city as a result of increased in property values directly surrounding the orange bus line. Again, this analysis was only done specific to the orange bus line, not the entire compressed natural gas fleet. However, we wanted to share it with you because clearly it is very important. Again, referring back to this chart for the last time, you have ROI in blue, SROI in orange, and now with the localized social value added, it moves that SROI curve even further to the right, creating more value and turning it into the green line you see here. So, wrapping everything up, our recommendations for LA Metro is that they continue allocating resources to building out this model, specifically to include the specific localized social benefits that we were able to find with the orange line to the entire compressed natural gas fleet and ultimately their entire operating fleet. As I said before, our goal is to not have this tool replace a traditional ROI tool. It can't do that. It simply can't. But we want it to be used as a supplementary tool to help quantify these benefits that are often overlooked, but that are very important to the stakeholders, specifically LA Metro and government agencies, as there's much more at stake with them as opposed to private entities. Thank you.
Chris, I didn't understand the part about the user valuing the social or environmental benefit from 1 to 10 and inputting a value. How does that work?
Is your question more on how it works throughout the model or why we chose to do that?
Both.
Both, okay. So in the model, let's go back to it. Okay, so you have low values and high values. As I explained in the presentation, so we took our information from the Clean Power Plan and they have a range of values, low values and high values, because by nature, these values are not specific. There is no exact value for a reduced ton of PM2 or PM2.5. So we wanted to create, the reason we have a user input is specifically because, for example, for a project out in LA at the Port Authority, they are extremely concerned with localized emissions from the freight, the trucks, taking the freight off the ships and driving through neighborhoods. So there, if they were to switch over their trucks from diesel to compressed natural gas, it would reduce emissions significantly in that area and have a direct localized benefit to them. So they would weight this probably at a value of 10 because it's that important to alleviate health impacts for their society. Whereas if you're focused on, if you want to put up a solar installation on your roof, you don't really care about mitigating emissions, you just want to save on your electricity bill, so you'd value that less. And another important thing was that what I stressed in our worst case is that even at the lowest values for all of these emissions, you still saw a positive NPV and a high IRR, excuse me.
Thanks. So I appreciate that, a lot of your background material came from the Clean Power Plan. Can you talk a little bit about how you developed the figures behind quantifying the value of safety and active transport?
Sure. So safety, we found from a few specific studies. I can't name them off the top of my head right now. They are in our paper. But it basically breaks down, it assigns a dollar value per type of crime committed. So I believe it was $8-point-something million for a murder committed. It was a lower value for, let's say, graffiti on the side of the bus. So you had an average values of those in the area and a reduced crime rate in that area after the orange bus line, and we used those numbers to quantify it in that sense. And then, I'm sorry, the second question?
The active transport piece.
Yes, so similarly to that, there was one particular study that we found that assigned dollar values to increased fitness of society, as well as mobilized in relation to mobilizing transport from a body perspective, so through biking and walking specifically, associated with per mile of bike path as well as footpath. So we used the mileage of the cycling paths and the footpaths of the orange line and multiplied it by the factors that we found within that study to find the benefits here, as well as the usage of the orange line as well, so the passengers associated with that.
One last question.
Thank you for the presentation. My question is regarding the discount rates used. So I see that you used different discount rates in 3 different scenarios.
Yep.
I don't know. I would assume that, for example, the best case scenario is the cost of capital of a city, right? And I don't know if you have some reasons of why to increase in those proportions the discount rate for each scenario. Or just an arbitrary selection, I don't know.
Yep. So the 4.5% is actually LA Metro's expected interest rate for their bonds that they're paying off for their bus system for 2016 and moving forward. So that was our expected. That's why we used that. As far as best case and worst case, it was more of just best case if their new, especially like their new bond measure that just passed recently in the election that wasn't quantified in that 4.5%, if there would be a lower interest rate on that, just depending on the loan that they got. And then same thing, worst case, if there was a higher rate to that, more of just prepare for the worst and see what could the best options be for this situation.
Okay, thank you very much.
Thank you.